Okay, everyone, we're going to get started here in the next maybe 5, 7 minutes-ish. We just sent out another email blast to make sure people are able to join. So we'll probably start right about 4:05 on our last presentation of the day.
You pack your shit.
Okay, I think I'm going to get started with just our baseline introductions, since I think everybody who's on here has been on for at least one other presentation. So you guys are probably tired of hearing me introduce myself, but I apologize because we have to do it. Thank you guys so much for sticking around. I know this one is the final home stretch. We're at 4 to 5 p.m. Eastern time here. So really appreciate it. This one's not that long of a presentation, probably only lasts about that 45-minute mark. Um, so yeah, this will complete our continuing education credit blitz. So like I mentioned yesterday, because we had all of the troubles on our WebEx, what we're going to end up doing is sending out a survey to everybody who was registered either on the WebEx or whose names we got here just from you guys being online. And then basically what that will do is there's a couple different questions, just some feedback for us on if you found these sessions helpful, what we could change, what we could improve on, as well as if you have any ideas for other CE credit presentations like this. And then questions 4 and 5 on that survey will be if you do want a continuing education learning unit for these presentations. All we need is your name, your email, and your company name, and we can get you over those certifications. So that survey will be open for 2 weeks. So you will have until January 3rd to complete that survey. And then we will get you those certifications probably within a week or so after that. But if you need something sooner, just let me know and we can definitely try and make it happen for you guys. Without further ado, I think I'm going to get started. I think we're pushing it with it being 4 to 5 p.m. on a Thursday before the holidays. So we'll just go ahead and jump right in. Again, my name is Emily. My counterpart is Mustafa Hassan. We are the consultant specialists for Delta Controls. And this presentation will be all around building wellness. So essentially our energy codes, lead in well, so some of the certification programs and how that all integrates within your building automation system. So the idea behind this presentation and then our next set of these presentations is to go a little bit deeper into some industries and kind of show you guys how this might actually help in the real world and in some projects that you might be involved in. As we've said before, we are able to give continuing education as a provider through AIA. All of this content is copyrighted. And without further ado, we're right about at that 4 or 5 mark. So we might see some people straggle in, but tell your friends this is being recorded so we can always send it out to you. Okay, so building wellness in general, what we're going to go over is some industry trends in building energy codes, overview of the standards that we're seeing in our industry. We'll talk about HVAC and building wellness, specifically around the program's lead and well, and then get into some ESG reports, some examples, and even a little bit of skepticism. So this is kind of, like I said, a more overarching presentation where we want to take this. So this one is actually going to be included in our next learning series. And what we'll actually be doing is breaking this out into different vertical markets. So what we'll focus on next year for our CE Blitz in the springtime is going to be more along the lines of those vertical markets and solutions based. So for this one, it'll be, energy solution based. We are going to have one around healthcare, maybe something in higher education, and just some of those big industries that we all tend to see and play in on a daily basis. So this will really lead us into our next CE credit blitz, which hopefully you all attend as well. So just an introduction into what we consider this concept of building wellness, right? It's just really, truly, as the world is grappling with all of these challenges that are involving climate change, clean energy in our building market is definitely becoming more important than ever. It is really being talked about on a day-to-day basis. Buildings in general are accounting for a significant portion of global energy usage and carbon emissions. So, like it or not, this is something that we are seeing on a relatively frequent basis. It's being talked about. They say no press is bad press. Well, in this case, it might be some press that we need to make some changes based off of. So, it's not just here in North America. This is an across the globe initiative. Governments are really starting to tighten energy efficiency, create different standards, and make it truly imperative for building owners to adopt all of these sustainable practices. The shift that we're seeing is really being driven by a combination of a lot of regulatory pressure, which we'll go into, but even some financial incentives, as well as just the advancement of clean energy technologies. So we are miles ahead of where we were in the 50s, 60s, and 70s. And so now we have all of these new initiatives, but how are we starting to implement them? So there's a statistic in the upper right there that said that an estimated of 75% of US buildings will be new or renovated by 2035. So this is a statistic that's at the top of the Department of Energy. And essentially what's happening is these building energy codes are ensuring that they're using energy efficiently over the life of the building. So this is, again, an estimated, you never really know if these statistics are true, but it is something that, our government and governments across the globe are really putting a focus on as we keep climbing into this new world and all of these new initiatives. This is kind of the underarching of why we're talking about this. A couple of trends within our industry specifically. So I say our industry, the HVAC industry as a whole. We're starting to see this idea around energy saving systems. Almost all manufacturers right now are going to have some form of device or some form of solution that is being used to analyze environmental conditions, occupancy conditions, temperature, how much energy is being used. We're seeing this on a pretty frequent and rapid basis. So it is definitely something that we're seeing, every manufacturer is leaning towards creating something around the energy savings market. If we want it to be something that is fast acting, so if we're talking about that control system, we want to be able to provide the exact heating and cooling necessary. We don't want to just be in that 6% deadband mode anymore. We want to create something that has that significant energy savings while maintaining our occupant comfort that we've all gotten so used to. Um, Smart HVAC systems. So we mentioned this before, but there is a statistic out there that says around over 70% of American households are equipped with at least one smart device. Similar expectations are now being passed on in the commercial space. So it's really important that our HVAC devices are being designed to be interoperable and work just like our smart HVAC systems at our homes. And finally, again, analytics. Analytics are a huge piece of this. We just talked about, strategies for AI with Jason for the last year, and that is something that is at the forefront of people's minds. And so this idea to be able to analyze and aggregate all of this data for green initiatives is really something that we're seeing as this industry trend over and over again. About 5 years ago, 10 years ago, we saw this concept of IoT devices, and now we're just taking it an even step further in our world. That being said, this actually came from a study on Deloitte Center, and they were asking a group of real estate, so building owners. This was a real estate study that was done. What are the biggest initiatives for the future of their building? So this was from building owners. And if you look at the top there, it says that 45% are investing in the Internet of Things. So this means that smart tech is a top initiative. And with smart tech comes a lot of these other building wellness and energy initiatives as well. You look on there too, net zero buildings are achieving record rents, not only just record rents in the monetary value, but they also are getting higher rent rates in general. So you're seeing, especially after we saw everybody go home to work for a while and people are just now starting to funnel back into office spaces. It's a big deal trying to get tenants back into some of those office spaces instead of working from home. We're starting to see a lot of initiatives around making our buildings smarter, easier to be in. And with that comes a lot about adopting new strategies within those buildings. So you can take a look here at all of the different ideals for what building owners are definitely worried about and considering in their future. And a lot of these are exactly what we're going to be talking about and exactly what a lot of our industry is working towards. So I think it's an important piece to start with. We always talk about the grid. I hear it all the time, oh, yeah, we're overloading the grid. Well, what is the grid? So a definition is just the electrical grid is this network of power plants, transmission lines, distribution systems, and all of it is delivering electricity into homes, businesses, and industries. Basically, the way that this functions is that energy is produced at the power plants, excuse me, and then it is being sent across high voltage lines to substations. Substations are lowering down that voltage for safe delivery into homes and businesses. What's happening right now is that we're seeing a higher demand than normal. And so this whole system of the grid is really based on trying to balance supply and demand. So operators are really trying to ensure that the generation is matching consumption in real time. And that is very hard to do. And the reason that it's so hard to do, and a lot of the times of what we're seeing when we're saying, okay, well, what really is the grid? It's because a lot of these concerns are growing, right? So we're seeing record demand right now. So this statistic here came from the US Energy Information Administration. And basically all it is saying and what it is forecasting is that 4.1 billion kilowatt hours in 2025 is going to turn into 4.18 in 2025, as well as this surpassed the record from 2022. Realistically, what we're seeing is that this surge is being driven by increased demand from a lot of different areas, but we're seeing pretty high ones from data centers, from manufacturing, the electrification of transportation and buildings in general. As these buildings are becoming smarter, that record demand is just going to keep increasing and increasing. That accelerated load growth is right in line with what we're seeing as record demand. Essentially, we hit the peak that we have ever hit on August 2nd, 2024. It was 7.1 million megawatts of natural gas-fired electricity was generated just in the United States. This was actually 6.8% more than the year before that. So it's definitely something that is highlighting how much more and how much quicker we are becoming more dependent on a lot of this electricity and a lot of these excuse me, a lot of this generation capability. Just as another statistic to throw out there, 9 out of the 10 days with the most natural gas fired electricity generation occurred in summer of last year. So it's definitely becoming more and more, and we'll talk about why that is, but it's definitely something that is at the forefront of a lot of folks' minds, and it's not just pie in the sky anymore. We now have some pretty significant data points to say why some of these things are happening. So when we look at the big differences and the reason that we're talking about the grid so much and the reason that we're seeing all of these load demands increase so much is because of a lot of things, right? Electric vehicles, this is a big one. Growing EVs definitely add significant load to the grid because you're pulling in more of that clean energy. AI is huge. And actually, this is pretty interesting. I just saw a study that was kind of in between AI and data centers, and we'll go into it here. But basically, what it was that on average, just one user scrolling on TikTok for 30 minutes, so just one user for 30 minutes, is the equivalent to of carbon emissions is the equivalent of about driving in a car for 12 to 15 miles. And that is the equivalent of using a microwave for about 8 hours. So one user scrolling on TikTok is about the equivalent of using a microwave on electricity power for about 8 hours, or driving in a car for 10 to 12 hours, 10 to 12 miles. And then on top of that, they just came out with a new one. And actually, this was a statistic that was produced and calculated on ChatGPT, which is pretty interesting, as Jason was just talking about AI. So it's one of those ones where we did a query for every ChatGPT query. So just one single query generates about 20 grams of carbon dioxide on average. So this is like driving a gasoline car about 1 mile. So if you take that and extrapolate it with about 100 inquiries, is the equivalent to running a 50-watt light bulb for about 100 hours, which is the equivalent of charging your smartphone about 500 different times from 0 to 100%. And this is the equivalent of driving an electric car about 20 miles. And so this is, again, just one user with 100 inquiries. So, we think about this and we start extrapolating that out, we're really seeing a lot of these high energy usage trends, just with those top three being new additions to the grid within the last 10 years in a really high aging capacity, right? The last two on there are going to be aging infrastructure. So if you look at a lot of the buildings that were built in the 60s and the 70s, the grid is kind of struggling to meet those needs with electrification, new renewables that are on them. The building envelope wasn't necessarily as good in the past. Some of those materials weren't as good. Talk about glazing of the windows. We're really starting to see how some of our older buildings are taking more and more energy to create that occupancy comfort that we've gotten so used to. And finally, the one that's on there too at the very bottom is just weather impact. And this is something that the Department of Energy definitely focuses on. So they have said that there's a couple of these different weather impacts when we start talking about high energy usage trends on a year over year basis. So that being said, something that the DOE is focused on right now is the concept of energy resilience. So energy resilience is going to play a predominant role in shaping new energy codes. And what this is basically it's the ability to operate your building and all of its energy services, such as your heating, cooling, ventilation, critical plug loads, and shelter during and in a response to a major disruption. And the reason that this is so important is twofold. It's kind of talking about your passive survivability. So what this is saying, like your ensures a safe indoor thermal conditions during extended energy outages, and making sure that it is grid resilient as well. So basically saying that we're not going to be overloading our grid during peak demand, reducing energy supply constraints and those risk of power failures, right? A couple of years ago, we saw a lot of brownouts. We're seeing a lot of blackouts. That's really what this is focused on and saying is that we want to try and mitigate that as we move forward. Um, Energy resilience is really just being driven, like I said, by the Department of Energy for this purpose. And we'll talk a little bit more about that on the next slide here of why and just the actual numbers that are going into this. So this is a map that they have on their website that basically states which of the states have really begun to create energy resilient buildings. So these are just of the states and jurisdictions that are being tracked, but our green states are going to have the higher energy resilient buildings. Red states are going to have the lower ones. So you can kind of see where this fits in, and this actually fits in pretty well with what we see in our industry in code adoption as well. But what's happening here is that a lot of places are slow to adopt some of these hazard resistant buildings and all of this idea of energy resilience. And what's interesting here is that as a consequence of that, they calculate what is the expected annual loss. And for only 5 states alone that are qualified as having our highest annual expected loss, those states are going to be Alabama, Illinois, Missouri, North Carolina, and Oregon. Just between those 5, they're expected to have that loss of 13.1 billion. And the way that this is actually happening is through a lot of these impacts of economic impacts of disasters. So NOAA, the National Oceanic and Atmospheric Administration, has an estimation on their webpage that says how many disastrous events there have been, and they qualify a disastrous event being over 1 billion in damages. And this is just again talking through building damages. So this is just our energy. This is our blackouts. This is all of the things that are going into our energy related occurrences. And they are tracking that there have been 376 disasters. Again, that means over 1 billion in damages since 1980. And what's interesting of that is that of these, it's over 54% have occurred in just the last decade alone. And so basically what that is saying is that's where you're really seeing that high level of annual expected loss to come in, is that, if we can't have a energy resilient building, it's going to start costing us more and more money as we're seeing more and more of these quote unquote disastrous events. And just, so you guys are aware, the damage in that 40-year period, they calculate that, and this is again through NOAA, they calculate that to be somewhere north of $2.65 trillion over the last 40 years. So it's definitely something that, as we start to track this more and more, it's going to become more and more in play, and it's going to really start to shape a lot of the legislative action that's then being funneled down into our industry. So that last bullet point there is talking about how just within the last year, 2023, there's been approximately 99 bills related to energy resilience that have been initiated in different states. So it's definitely addressing the needs of grid reliability, redundancy, efficiency, And again, trying to mitigate some of this huge economic loss and impact, as well as, again, just focusing on safety in general and resilience of people in general as well, right? So, from all of this, we see that a lot of our energy codes have been adopted from a lot of these different industries and different standards. So, when it comes to our HVAC standards, our big one, which we talked quite a bit about within the last couple of days, is going to be through ASHRAE. So, ASHRAE in the 70s, they introduced two different codes that we still know and use well. It's ASHRAE 90 and ASHRAE 62. So ASHRAE 62 is the one that talks about ventilation for acceptable indoor air quality. And ASHRAE 90 is going to be really the first ever comprehensive energy efficiency standard for commercial buildings. And it truly targeted HVAC systems and building envelopes in general. So that's really what we saw within the 70s. In the 80s, we saw an enhancement to these strategies. So, within 10 years, they said, okay, that was a great standard. Let's push the envelope a little bit more. Let's add lighting into ASHRAE 90.1. Let's add a minimum ventilation rate for ASHRAE 62.1 at this time. And that's really what we saw throughout the 90s, or excuse me, the 80s. Once we got into the 90s, we saw a few more of these green initiatives come into play. So 1998 was the first time that we saw something called LEED come on the radar. And that's something that we'll talk about. And this isn't necessarily a standard per se. It's not a national energy code, but it's worth putting in here because it is definitely one of the most recognizable rating systems. It's a certification for energy efficient and healthy conscious of building designs, right? Also within that, we saw the Energy Policy Act. So in the 90s, we're starting to see even more come into play. We're not just looking at ASHRAE now, we're starting to see this as a broader sense. We get into the 2000s, and again, we just get a few more updates to everything. And that's really what we have started to see for the last 20 years is that we're seeing everything now just get a little bit pushed further and further and further, trying to make these buildings closer and closer to what is now net zero energy goals. So net zero energy goals are something that all of these standards have now started to put into play. We see within the 2010s, the building well standard, that was again when ASHRAE Guideline 36 first came out. And then IECC came out around that same time, and we'll talk through what each one of these means during just a second. But so that's really a brief timeline of how some of these codes have started to get into play. So from 1975 all the way up to where we are now, there has been significant jumps throughout each decade, and definitely again we're just pushing that envelope further and further every time that there's a new standard that is being adopted. So the three that we're kind of, well, I say three, we're going to put them into three kind of buckets right now that we'll talk through. That first one we've kind of already spoken about quite a bit, which is the ASHRAE guidelines. So 90.1 last updated in 2022. We also have 62.1 and now guideline 36. So this is really what is focused specifically on the HVAC systems inside of buildings in general. If we look to the very far right there, we see IECC. That's just the International Energy Conservation Code. And this one is really highlighting the growing emphasis on the need for integrating renewable energy while still having that energy use based on grid demand. So this is really focused on grid demand. This one, this standard, it actually does have a residential branch as well as a commercial branch. So you'll see that for both when we talk through IECC a little bit later. But between the two of those, that really is the majority of the national codes that we see going into place when we start talking about our industry. If we look in the middle there, I decided to just include three state-focused energy laws, even though, again, we are seeing more and more of those come down the pipeline. Like I said, it's been about 90 or 99 different pieces of legislation that are talking about improving efficiency standards in buildings on a state-by-state basis. But the three that are kind of the most prevalent right now are going to be California Title 24, Local Law 97, which is in New York, and the Washington Clean Buildings Act. This is House Bill 1257. These are just three that I chose because they are probably the most forward fitting of a lot of these state energy codes. And a lot of them are what we're seeing start to have that trickle down effect. So California Title 24, if you guys remember from Guideline 36, is actually one of the ones that guideline was built upon. So it's definitely one that we're seeing have quite a bit of adoption, not just in California. So it'll probably, span the breadth of the US here at some point in general. So let's talk a little bit about what these actually are and which ones are kind of be the strictest. So it kind of goes back and forth on what people are saying, but the strictest standards in general speaking are probably going to be Local Law 97. So Local Law 97, it applies to larger buildings in New York City. The reason that it's kind of considered the strictest standard right now is because it does have aggressive carbon emission limits as well as pretty heavy penalties for noncompliance. Those penalties, I believe, are going to start in this next year unless it gets pushed out. But it is definitely one that is, its whole focus is on reducing greenhouse gas and emissions. And it's got some pretty specific targets around that net zero time frame for 2030. So it's definitely one of the ones to keep your eye on, especially if you are in that market. House Bill 1257, that's the one that's the Washington Clean Building Act. I would say the Washington Clean Building Act and Title 24 are really neck and neck for being a strict standard. The only reason that we have House Bill, the Clean Buildings Act first, is because it is the only other one right now that is having these penalties being enforced on a pretty regular basis, again, starting in 2025. Their penalties are not super high. I believe we go into them next, but they're definitely just targeted at getting people to be early adopters of these standards. And then Title 24, it does apply to all buildings in California. It's got very high, strict, and rigorous energy and efficiency standards for both new construction as well as major renovations. Its focus is around the same thing: energy efficiency, renewable energy integration. That's a big piece of what Title 24 does, is making sure that these buildings are having these renewable energy integrations into their buildings, as well as reducing energy consumption as a whole. IECC and ASHRAE 90.1, they don't necessarily have any penalties, and we'll go into this as well, but they're more across a broader spectrum. The IECC does apply to both residential and commercial across the US. The stringency is really moderate to high, just depending on the version that is adopted by each local jurisdiction. And we'll look at a map of that next to kind of see where maybe your state lies. Focuses on that one is going to include a little bit more along the lines of the building design itself. The building design meaning insulation, windows, the HVAC system. And so it's a little bit less on the energy efficiency when it comes to those renewables and consumption, and meeting those net zero standards. ASHRAE 90.1, like we've talked about a few times, this applies directly to commercial buildings and high-rise residential buildings. Its stringency is pretty moderate in the fact that it does provide minimum energy requirements, but that's about it. So its focus is on that energy efficiency design of buildings and systems, which is what we've really talked about throughout this whole series of blitzes together. So when it comes to where all of these national energy codes are being adopted and where all of you might sit. So this is according to the Department of Energy website as of September, I believe is when I pulled this. So September 2024. So on here, the darkest green are going to be the folks that have adopted ASHRAE version 2019 or above. And that's really where you want to be at, because again, throughout all of those different updates, they have started pushing the envelope higher and higher for what you need to be doing to meet those standards. What's interesting is we do have still some states that have not adopted a statewide code. Not to say that they don't have, jurisdictions in general, but those are a few of the ones that don't necessarily have that code adoption. This is a map, again, very similar. This one is for IECC standards. So you'll see, some folks might not have adopted an ASHRAE standard statewide, but they might have one for IECC. And then again, on here, California kind of gets its own color in general because they have their own Title 24, which is kind of considered one step above that. So again, this just kind of puts it into perspective of where we're seeing this happen on the map in general. And then this is broken down even further. by the American Council for Energy Efficiency. And they went in and they actually did a ranking system. And this is a pretty neat report to read on how they ranked everybody. And they actually did a few that have been most improved over the years, and kind of like why all of these ranking systems are what they are. And so again, an interesting one, and I picked this one out because I'm from Colorado, so it just, stood out to me. But an interesting one with Colorado is, even though it doesn't have a adoption of a statewide standard and it has the minimal adoption for IECC, they're still ranked 14th on how they decided to rank the energy efficiency for these states. So it really does kind of depend. It's a super interesting read if you're into that sort of thing, which I was. But on here you can see that they did rank New York as 1 and California as 2, which is actually kind of an interesting back and forth that over the last couple of years that shifted. But again, just the fact that now, New York has that local law 97, we're seeing a pretty high uptick in the energy efficiency codes that have been adopted in New York and California. So when we look at these latest updates and what's new in some of these codes. So we'll look at right now, this is IECC, just kind of some of these differences between 2019 and 2024. And what's really interesting, if we look at those top 3, it's actually something that's been pulled back, which was an interesting piece that happened in 2024. So a lot of these have been moved to the appendices. So electric vehicles, jurisdictions can adopt these provisions separately if they choose to. The same thing with solar and electric readiness. So again, that's talking through those renewable energy features. The same with all electric provisions and a net zero path. So the net zero path is something that was added and moved to the appendix as a resource for people to be able to start to get their buildings on track as a net zero path. When we look at some of these things that, in our industry, specifically what have changed in 2024, the biggest thing is going to be power receptacle control. So it's a significant change that now is automatic plug load control is required in certain applications, such as like offices, workstations, classrooms. And it's definitely been a minimum of 50% of all permanently installed 120 volt 15 amp receptacles must be controlled. So this is a pretty big difference than we've seen in the past. And again, just focusing on the fact that we want to control more of our energy usage. Another one in terms of lighting, there's been some big trends that have added to IECC and ASHRAE as well. So just again, commercial building energy codes over the past 20 years have been slowly but surely shrinking lighting power allowances and increasing their lighting control requirements. These are just a couple of things that were different from the past versions of IECC and just things that they're starting to focus on more. Similarly with ASHRAE, we saw a few pretty interesting updates. So one of the biggest ones in 90.1 was the on-site renewable energy systems. So this was actually the first time that the standard had anything like that required for on-site generation, which is interesting. Kind of another thing that they did twofold with that was energy credit. So you essentially get like this menu of 34 measures in order to meet that required energy credit points. And it does actually, there's solutions based on your building type and your climate zone. And that's a pretty interesting update within, I believe that one was not this past one, but the update from before that. We talked a lot about the different mechanical systems that we are controlling using a building automation system. And this definitely drives right into home of what ASHRAE 90.1 is saying. They introduced a mechanical system efficiency coefficient. So essentially what that does is it measures the total system performance ratio. So it measures, it's a measure of the entire HVAC system as a whole, and it considers all of the interactions between components. So everything that we talked about throughout BAS 103 and 104, it has a real world effect when we start talking about some of these different projects, when we start talking about some of these different efficiencies and energy efficiencies that you're going to have to start to keep up with when we talk about the standards. A few on the right there, they included an air leakage testing. Buildings are supposed to now have a maximum air leakage rate. And again, this is going back towards that building resiliency category. As well as, again, they did the same thing with lighting power allowances. So they're updated lighting power allowances, shrinking and shrinking. as well as they did include an additional guidance for using emissions on site and cost-based metrics. So between the two of them, every about 2 years, and they're staggered, we do see an update. And those updates are generally trending more and more towards stricter energy efficiency metrics in both IECC as well as ASHRAE 90.1 and 62.1. I promised that we would talk through a little bit about compliance. So are there penalties for any of these compliance features on our standards and are both on the federal and the state level? So I mentioned that local law 97 is definitely the most stringent one. So what we're seeing right now is that buildings that are exceeding their carbon emissions are going to face fines of up to 268 per metric ton over their allotted limit. There are also there are also penalties for them to have failing to submit their reports. So not only if you don't meet the metrics inside of your reports, you also can be fined for failing to submit the report in general and implementing your required energy conservation methods. This is one that we're Moose would be better off to talk to this one. And I think next year we are going to have something that's focused around this. But it is something that's interesting, to just make sure that people are doing the right things for the right reasons. We don't want this to be something where you see people that are just like, the fine's not that much, we'll just pay it, instead of implementing the building automation solution, right? We actually want it to be the fact that, hey, there is a real world issue with all of this building and energy, economic and environmental impact. So the reason for this entire building automation slide that we've had is that it really does help not only to promote that energy efficiency, but the savings that you can see on the backside of it from a cost perspective as well as from that energy perspective are going to be pretty great. Like I said, the House Bill 1257 in Washington, it does have a non-compliance penalty, but it right now is just up to $1 per square foot per year. Like I said, those penalties are really right now just designed to encourage early compliance and help with the significant energy efficiency improvements. I was actually just informed too that the House Bill 1257, it actually does reference Guideline 36 inside of it. So again, all of these standards and all of these guidelines and everything really is coming together for the same purpose. And so that's pretty interesting as well. Title 24 enforcement's handled at the local level. A lot of times through permits and inspections. Non-compliance is going to result in fines, delays in project approval, and potentially having to do the work again. The same thing kind of with IECC. It's really at a local level. ASHRAE is more tied to local building codes. So it's not necessarily that there is a strict non-compliance law to it, but it can lead to, I guess, fines, project delays as well, and even additional costs in order to bring those buildings up to code, just depending on what level of that ASHRAE standard your jurisdiction has implemented. And again, that goes back to that state by state map. So we'll talk through just briefly on LEED and WELL here, just because they're two kind of the biggies when we start to talk about buildings certification programs. So LEED is going to be our leadership in energy and environmental design. It's important to note that both of these here are businesses, so they're not like a national standard by any means, but we have LEED and WELL is more focused. So LEED first is more focused on the building itself, and WELL is more focused on the occupant health of the people inside of the building. So we'll go through just a little bit of what those mean now. So LEED is probably the most widely used green building rating system globally. The certification levels we'll go through just very briefly, as well as the focus areas of how they're actually determining what level of certification you get within the LEED program. So the 4 and now technically 5 different levels of LEED certification, they just have regular certified, silver, gold, and platinum. This is mostly just for you guys to go back to if you're ever interested in knowing how all of these are calculated up, and if you ever do want to take somebody through a LEED project. And then the 5th one on there that's not on the slide, but LEED now does recognize net zero energy buildings. So this is going to be buildings that have a total energy that is consumed by the building that is equal to or less than the renewable energy that is generated on site. So those are going to be ones where the building is actually making its own energy or not using energy in general. And again, that's LEED net zero. The LEED categories and crediting system, how this actually works, there's a couple different crediting systems for LEED. So our categories are going to be things like indoor environmental quality. And so again, that's for us called the IAQ, right? And we've been talking about that over and over again. And you can get up to 16 points for this. And this is one of their biggest categories. So focusing on improving indoor air quality, lighting, overall occupant comfort, this boosts health and produces productivity. Again, we mentioned, there are studies that show people learn better in better environments. So that's why this is a category on there. Innovation and design, as well as regional priority credits, you can get different points for those. A couple other ones that they have are sustainable sites. So just encouraging people to, from the beginning, figure out where they're going to build their site in a sustainable way. Water efficiency, energy and atmosphere is their highest point-based system. And so this is directly tied to our industry as well. So this is anything that is incentivizing improvements in energy efficiency, as well as renewable energy usage and that greenhouse gas emissions reduction. So that's 33 points, which it's actually pretty interesting that when we're talking about our industry in general, between energy and atmosphere, indoor air quality, and just 1 point for something else, you can actually get all the way up to a silver LEED status. So our industry really is directly impacting some of these LEED credits and category systems. So again, when we're thinking about LEED, we're really thinking about the building itself. So it's IEQ and occupant comfort, and focusing on how to actually maintain that occupant comfort with the energy resilience is going to be kind of LEED's bread and butter. Like I said, this can actually take you all the way to a LEED silver category. So it really is what they're focused on, is around the building. These factors are really just going to create a healthier, more productive indoor environment. So when we think about something like this, we're going to actually go into an example of how you would take a project from start to finish. So kind of think through that. But the benefits of LEED at every level of certification is that basically you're going to have your environmental impact reduction. So this is going to be exactly what we've continued talking about over and over again, continuing to really this global effort to reduce energy consumption, lower your carbon emissions, and use your resources more responsibly. Like I mentioned in that first slide, increased occupancy and retention. There are a bunch of studies out there right now that are showing that LEED certified buildings tend to have both higher occupancy rates and costs. Lower operating costs overall, just because again you're implementing all of these strategies, you're going to see a lower operating cost. And again, all of these standards, like we've been thinking, they're all built off of each other. So when you start to employ strategies from Guideline 36, you're almost certainly going to have something around LEED accreditation as well. So by getting this LEED certification, you can ensure that you're actually being in compliant with a lot of those state regulations, as well as the federal regulations of whatever jurisdiction your area has started to comply with. The final point there at the bottom is a good one for a lot of folks, is that there are a lot of tax incentives and grants that are available per each different state, based on the idea of reaching LEED silver or higher. And those, I think we have a link on here, and if not, I'll put it on here, but those are actually listed on their website as well, of a few different tax initiatives and grants. And just as an engineer, as you're starting to plan this project and you're really starting to develop this project, that's a great resource to start to tell some of your building owners of, hey, yes, we want to implement Guideline 36, but have you thought about getting your LEED certification, for tax incentive purposes, for grant purposes, and be able to direct them to the right resources. It's just kind of that added bonus to doing the right thing, using your resources valuably, as well as getting a little bit of economic incentive around it too. So when we look at developing the LEED project in general, it comes in about 9 to 10 steps. The first one is kind of obvious. It's knowing all about LEED. So we kind of left that one out. But the other steps are going to be around conducting a preliminary energy audit. So this is what is going to be currently at the building or proposed. Developing an energy model comes next. And then you're optimizing your HVAC design for that energy efficiency. This is where we're going to use strategies like our demand control ventilation, like our trim and response, like using VFDs, creating some of that heat recovery. A lot of the things that we have really slowly but surely built up and started to talk about can now be used as we're developing this project. Ensure that you're meeting proper ventilation requirements. We've talked through 62.1. These standards are in place for a reason. And if you're going to develop this LEED project, this is what comes next in those steps. Finally, optional but valuable, integrating a lot of those renewable energy effects. We just saw ASHRAE 90.1 put that into play, is, integrating renewable energy. So, as you're seeing, all of these are tying into one another. So you may as well take advantage of it because it's definitely coming down the pipeline. Step 6 there is commissioning the HVAC system. As we all know, this is a super important part that doesn't always happen or that doesn't necessarily always happen appropriately. So this is another thing that commissioning is starting to being recognized on that state by state level. It is mentioned in the Washington Clean Buildings Act, House Bill 1257. They actually go into how to commission projects to make sure that they are using that functional testing to ensure components are working correctly. Final steps are to monitor and verify the performance year over year. Submit all your documentation to the U.S. Green Buildings Council, who is actually what LEED is developed by. All of these reports will go in your LEED application, and then from there, it's just developing your HVAC maintenance plan year over year to make sure that you're continuing to maintain those standards. So those are really just the step-by-step of how a LEED project would work. A couple of, well, not a couple, just the one different example right now. There are definitely buildings that have achieved a higher score than this one now, but for its time, it achieved a world record LEED score of 90.8. This is the Edge in Amsterdam. It achieved LEED Platinum status. But what's interesting and important to note here, so those were some of their HVAC innovations, but just from this, and you can actually read on there, they've done quite a few YouTube videos and white papers, but they've achieved over a 70% reduction year over year in HVAC related energy use. So it truly was an example of where these strategies were in play and working well, right? The next one, we're just going to kind of fly through well because it's a little bit less focused on the building itself. It's focused more on people. But within that, obviously, your building needs to have all of these different systems in mind to maintain that comfort. So similarly, there's certification levels. It is oftentimes integrated with other standards. So we see that more often with WELL, that it will be integrated with a LEED building. Its standards and the way that it works, very, very similar. Bronze, silver, and gold. Again, platinum as well, and it is a points by point basis. The 5 steps for a WELL certification are going to be registration, your documentation that's required, your performance verification, then they actually certify your building, and then the next one is going to be recertification year over year. The different concepts and performance areas from WELL, they're pretty similar to LEED, but let's just take a peek at them. So they're going to be more along the lines of, like I said, focusing on the occupant. So thermal comfort, that's exactly what we've been talking about over and over again, occupancy comfort, right? Making sure that buildings are providing very comfortable environments for their beings inside of their buildings. Your sound, that was a big one that we talked about in BS 101, specifically in hospitals, right? That we need the noise pollution minimized. Materials, mind is an interesting one. So it's promoting a enhanced mood and fostering positive emotional state. A sense of community, that also has 10 points there. So you can see on here of this slide, materials is going to be the largest category for them. It's 14 points. But then we come to air, and air is our biggest category, which again promotes all of that well-conditioned, ventilated indoor air quality, which is what we've been talking about over and over again. So, again, just by using some of these strategies that we've implemented, you can get up to WELL bronze status. So it's not as intense as it is with LEED, but again, some of these strategies that are going to ensure a more pleasant environment for inside of a building. When we talk through WELL, again, it's prioritizing and optimizing occupant health. So these can be ways like your indoor air quality environment. You're focused more along the well-being. So WELL even does things like it goes so far as to say fitness spaces and access to nature, ergonomic furniture. So there's a lot that goes into these WELL buildings, which is why we, as in our industry, would normally focus a little bit more on the LEED side of things, but we see these paired together all the time. So I did want to include just one example that has both. So this is One Vanderbilt in New York. And again, we're seeing New York as one of those standouts year over year. So they achieved LEED Platinum, and you can see there's some pretty significant statistics around what they were able to achieve. So, they have a crazy water conservation. So they reduced their water usage by 40%, 30% more efficient than similar buildings year over year. They're well as well. They were well platinum. And so they have, indoor air quality monitors. They have a really crazy advanced filtration system in there. If you look up this building, it's pretty wild. But just as to say that, when we start talking through these strategies in general, it's really interesting what is coming down the pipeline and how all of these are working together to promote that occupant experience, but still, again, maintain focus on the fact that our grid is being overused, year over year, and we have all of that data to back that up as well. So finally, we're going to go into just a few different real world benefits and challenges. And I apologize for the fact that these slides aren't that pretty. These were slides that we actually just added because myself and Jason, we had this question asked from one of our consultants. And the question was around, yes, this is all well and great. We all want our building to be a smarter building. Nobody's going to say that we don't want to reduce our energy usage in our building, but at what cost was the question. So, we talk about all of these strategies using AI, right? So we talk about, hey, can we make our building more efficient by making our building smart? Well, what cost does that really associate with a AI cost in general, right? I know there was that age-old statistic of how much water did it take to send an email. Well, now we have something even bigger, right? So the example that I was able to find, and again, I apologize for these slides, but it's really just about the data here, which it's super interesting. So the best example I was able to find was Microsoft. So Microsoft actually published two papers, and I have the links to the papers on the third slide here, but they published two papers that were about 3 months apart from each other. So this first one that they published was talking about how much achievement they had with their building automation solutions in all of their new buildings. So this was new buildings. I believe it was from 2020 and above. But basically what they did was they had this deployment of an insane amount of integrated sensors within all of their buildings. They were enabling real-time monitoring, and they were doing so much in regards to operational efficiency. They were doing this crazy thing with algorithms for optimizing HVAC and energy patterns, and they were utilizing some pretty advanced capabilities and advanced sequencing for making these buildings smart buildings. And they actually touted in their AI-driven building management systems for predictive maintenance and autonomous controls. So this was their big thing, was like utilizing AI, utilizing all of this IoT capability to promote energy reduction and consumption, right? So they saw in that 1 year, they saw a 20% reduction in energy consumption at Microsoft campuses. But then 3 months later, they came out with this other paper around the cost of their data center operations. So this was actually a separate paper that talked about their emissions impact. And so they actually saw in Microsoft in general a 29.1 increase in their total emissions. So this is not just through their campuses and their buildings, but this is also through, everything that is tied to it. So take these statistics with a grain of salt. But basically what they found was that this 29.1% increase, they attributed it exactly to an expansion of data centers to support their AI and IoT systems. So they had all these data centers that now have to support AI and IoT systems in order to make their buildings smarter. What we saw as well there was a 23% increase in their water consumption to meet the cooling demands for their data centers. So overall, that was not a very pleasant report for them to function there to publish there, because they saw a 29.1% increase, but they're very open about it. You can read the whole report here. But it was, again, directly tied to AI and IoT systems. They saw their power requirements for AI data centers growing at 160+%. So it's huge, right? The economic impact and the emissions and the energy was greater in that year over year than it was in the savings. So, we take that again like a grain of salt. The savings on the energy was 20%, but then their data center costs were a lot higher. So, again, it's not a one for one. It's just something that is really interesting to think about, when we start thinking about using AI in this awesome manner and again, doing all of the right things. But we also need to be sure that we are taking into account what happens on the downstream of that. So there might not necessarily be a good solution right now, but it is something that is interesting to think about when you're going through. Um, on that note, a couple of things that are measurable savings and something that you actually can look at in a real world environment are going to be your ESG reports. So a lot of times companies will publish their ESG reports, and this is for one of the ones actually for our parent company, Delta Electronics. And this is going to be more along the lines of that sustainable management and their sustainable key performances in a lot of the categories that we've just talked about, not just from an energy savings perspective, but as well, when we're talking about well buildings and the overall environment. So you can actually go in and look up a lot of these ESG reports for LEED and well buildings and see some of these measurable savings that are actually happening. So I like to include that right after the, skepticism in the Microsoft example, but there are so many of these measurable savings that we're seeing year over year with ESG reports in general. So a couple of the benefits of compliance when we're talking real world are going to be, there's a lot of studies out there, but the majority of the percentages that I have been seeing, just when doing research for a lot of these case studies that we're doing is around 30% on energy costs annually when you're looking at a large scale building. When you're starting to put in some of these energy saving mechanisms. So you can also have your increased building value. So we saw, that study when it comes to high value real estate, we're seeing that LEED certified buildings can often increase your property value anywhere from 4 to 10%. It makes this really attractive to investors because they know that the compliance with the standards, not only are you not going to have to pay those fines, but you're also seeing that, at least X amount of energy cost savings per year. And then finally, what we're all really going towards in this presentation in general is that environmental impact. It is definitely something we all see it every single day. It is being talked about, all of our different countries globally have, different standards that we're trying to meet by 2030. So it does contribute to global efforts to combat some of these issues that we're seeing when it comes to energy usage in general. And again, our industry is a big piece of this, which is cool, right? It's a good responsibility to have when you're starting to sell this to somebody or when you're starting to really just have that conversation with building owners. And then the final piece of this, like I said, I think this is the one where we actually have a link to it, is around some of the government funding grants and tax credits, just because, again, this is such a big deal in our world right now. California has some amazing solar initiatives. They have amazing initiatives in general when it starts to come to renewables and making sure that you are code compliant. So overall, it's a big topic, and it was, it's a little bit more overarching at this point. But what's happening is that, our industry and our standards in general are continuing to grow. They are continuing to push boundaries. They're continuing to promote energy savings, talk about energy resilience, talk about how much we're putting, energy on the grid, how much this is straining us. So what we're trying to get at here is that it is something to look forward to. It's going to be future forward looking. And it is something that we are definitely prioritizing, and we're committed to trying to, take that journey along with everybody else and making sure that we're creating these buildings to be smarter and also code compliant as we see these standards keep growing and growing. So that's kind of the thick of it. I know I took us right about until that 5 p.m. mark, so I really appreciate you guys sticking with us here. I'm going to stop sharing my screen here so that way we can just kind of close it out. If anybody has any questions, again, I know we're on that 5 o'clock mark on a Thursday before Christmas, but I hope that this was really helpful for you guys. Just going through this blitz in general. we really enjoyed doing this for you. I know that we're really going to try and do more of these in the future. So again, be on the lookout for that survey. If you don't get that survey, our emails have been plastered all over this. I think everybody has them now, but I'm going to remain on this chat for about another 10 minutes. If you don't have our emails, definitely put your name in the chat and say, hey, send me an email, and I surely will. Again, all of these will be recorded. We will send out these presentations to you, and we would love to do this more in the future. Moose and I, like he said, we do cover both sides of the country. So if you want any of these presentations in person, that's kind of what we're here to do, is really just educate and be a resource for all of our engineers. So I took you guys to 5:01, so it's happy hour. Sorry for those of you in California, you're going to have to start early. Shucks. Anything else, folks, as we go along here? All right. I really appreciate everybody doing this, sticking around. Have a good one. Happy Christmas, Merry Holidays, all the things. Oh, you guys are so sweet. All your nice words. Thank you, thank you. All righty. It looks like nobody needs the emails. Get people hopping off here. Stop this recording.